Welcome to this Week 5 lecture, a parallel exercise walkthrough. For exercise 1, our big picture objective is to insert records selected from one table as new records on a second table. Before we can truly get started with exercise 1, there are some preliminaries we need to take care of. And exercise 1 is going to work with populating a new table called non-game. And non-game is structurally very similar to our items table in the TAL database. The biggest description or distinction is that the warehouse field is not going to be used. So we need to drop that from the design. And we can, of course, craft the create statements to create that table by hand. And one way that we could kind of get a hint about that is to come into the item table and start looking at the design of that table and what goes into it, what the types are, and all that. But there's actually an easier way we could use to get started. So let me show you a little shortcut. I think you'll enjoy this. So we can come over to our item table, which is really the model or the template for the non-game table. And if I right click on it in my SQL Server Management Studio, there is an option to script the table. And I can script that out as a create statement to a new query editor window. Okay, so that is going to go get the metadata, which is stored in the system database about this table. And this is the statement that will create that table. Now we could just change it slightly. So instead of changing or creating the item table, we can come in here and edit it so that it's going to create the non-game table. And again, we want the item number, we want the description, we want the on-hand quantity, the category, but we don't need the storehouse. So let's just take that line and drop it out. And then we still want the primary key in its normal clustered key. So we can leave that alone. And it's going to create the item number as the primary key. And let's go ahead and run that and see if that works. Okay, so the command completed successfully. Again, if you come over and look at TAL, if you already had it expanded out, it doesn't ordinarily refresh this view every time you run a command here. So you're going to want to come into TAL and tell it to refresh. And now if we go look at the tables, we will see that we now have the non-game table created. And if we were to just select the top 1,000 rows, well, there are no rows. We've just got the table structure, but we see we now have the empty table structure, and we're ready to start in on exercise 1 in earnest, which is to insert into that table using specific fields and records from the items table. So we're kind of cloning a table from that, but it's not going to be the complete table, it's a subset. So let's go ahead and start a brand new query window and tell it to use TAL. So there's our database schema selected. And what we want to do is let's start with a select and make sure we have the select going correctly. We need to select certain fields. Let's start with all of them from the items table, from item. Okay, starting with that. Here's everything in the items table, but we don't want everything. We only want those things that the category is not GME, so all the non-games. Okay, so let's elaborate with a where clause. Where category is not equal to GME. Okay, so if we look down here, just a quick sanity check, we've got 15 rows. We should get less than 15 rows, and all the GMEs should disappear. And let's give that a shot. And indeed they do. So we now have the correct things, but we still have that pesky storehouse field in there that we're not going to need to get this table. So we need to select only the fields that we want. So again, we want the item number. Oops. Try that again. There we go. Item number. We want the description. We want the on-hand quantity, and we want the category, and we want the price, and let's see if that gives us what we want. So our item number, description, on-hand, category, and price, and we check that against the problem statement, insert into non-game table, item number, description, number of units on hand, category, and unit price from the item. Okay, so we got it. So this is the select query, but how do we take this select query and get the results into our new table that we've created for it? And so we simply take this query and elaborate on it by adding a line, and we say insert into, and then the name of our table that's going to receive the records, non-game. And again, for this to work, we have to have these field names, and they need to be compatible types and lengths and all that good stuff. But since we cloned it from the original source, that's kind of taken care of for us. So it wasn't that clever. So insert into non-game, select these things, and we need to be careful. We want to run this once. For one thing, if we were trying to run it a second time, because we're not auto-generating the primary key, it would end up the second time trying to duplicate keys, and that would create record errors. It would fail the second time. Let's see if it runs the first time. Okay, says that 9 rows were affected, and again, sanity check, that seems reasonable. And now let's just come down here and select star from non-game. And we're good to go. In exercise 2, our primary objective is to update an existing record in a table. For our second exercise, our parallel problem involves updating a record in the non-game table. Let's go ahead and paste in as a comment the problem statement for the parallel exercise. And the big picture objectives here, of course, are just to do an update on the new table that we've created. Okay, and so let's see, I don't even have to split that, that's so short. So in the non-game table, change the description of the item number DL51 to classic train set. So let's start by selecting everything from non-game. Oh, we better start by making sure that we're in this new query window, we've set the schema to tal. So let's use tal. There we go. And run that, and then IntelliSense will wake up. Alrighty, so there's everything from non-game, but we're interested only in item number DL51. Okay, so we're selecting the right record. Now that we've got the select working, let's transform this into an update query. So now instead of select, we're going to update non-game. And instead of select, we're going to set, and we're going to change the description field. And we're going to change it to classic train set. where item number equals DL51. And so just a pretty straightforward update query. And let's give that a run. And one row is affected, which is what we expect. And let's make sure that that change happened as we expected. So let's select star from non-game where item num equals DL51, and it should now say classic train set. And it does. Our exercise 3 big picture objective is to update existing records in a table using a calculation based on present values. Our third exercise uses TAL4 from the current chapter as a model. And the problem statement says, in the non-game table, increase the price of each item in category toy by 2%. So what we're trying to accomplish here is we're going to do a calculation on the current value of a row that we're updating. And we're only doing that for a specific filtered group, and that is where the category is toy. So before we start doing updates, let's do a select to make sure that our select statement, that our logic is correct in getting only those records that we want to modify. So let's start with select star from non-game. And again, let's make sure we're using the TAL schema and execute it. So there's everything. And now let's add the filter. We only want the toys. Okay, so here are only the toys. And what we want to do is we want to change the uh, price, not the cost, but the price by 2%. So one way we can do that is if we multiply something by 102%, then we will have added 2% to the total price. So let's do that. That's an easy way to address it. So select star, and let's add one other calculated field just to see it for a moment. We'll change this going forward to actually update the field. But let's create a new field, and that is price times 1.02 as plus 2. And here we go. So 89.49, add about 2% in that. It's somewhere, it's heading toward $100, so it ought to be $2 more, in the neighborhood of $91, and that's what we see. It's happening. So it passes a quick sanity check, and that looks like it's working consistently across the board. So this is the logic. Now we need to change this. So instead of putting it into a calculated field, we need to set the price field. So we're going to change this from a select query into an update query. We're updating non-game. Okay, when we put the table here, we don't need the from clause here. And instead of select, we're going to change that to set, and we're going to set price, and the price is going to be equal to price times 102. So we no longer need an alias for that field. We're putting it right back in its original field. Okay, and so kind of remember that our first record, we'll use this as a check, was 89.5 and it should end up being 91 and 28 cents roughly. Okay, and that should do it. So let's go ahead and fire that off. 5 rows are affected. That seems right. And then let's go ahead and do a select star from non-game where category equals toy, and there we are. So it looks like our updates have taken hold, and we're good to go. Exercise 4 focuses on inserting a record into an existing table. For our fourth exercise, we're going to be inserting a new record into our non-game table, and we're using TAL5 as an example. It says add the following item to the non-game table: item number TL92, description dump truck, number of units on hand 10, category toy, and price 59.95. And again, we can, of course, manually construct the insert statement, and that's fine. But again, a shortcut you might like is I go over to my non-game table and say, let's script table as an insert and put it into a new query editor window. So our old query that we're working on is right there, but it's created this new query window, and oh, look at that. It's got the whole template for inserting. And here's the neat thing about this is as long as I'm inserting every item, every field in order, item num, description, on hand, category, and price, which I am, I can actually drop that part and just say, what are the values? And here I have all the value types, but I don't have to specify the type. It's, the data type is already intrinsic in the field as long as the value that I place there matches that data type or can be converted to that data type. That will work. So I can just take this, make my little template. So I've got my insert statement ready to go. Come over here, and then let's just go ahead and fill it out. So our values were going to be TL92, and it's dump truck, and there's going to be 10 of those, and the category is going to be toy, and it's going to have a price of $59.95, and that should be it. Let's give it a shot. One row affected, that's what we would expect, and let's go check it. Select star from non-game and run that, and here we have TL92 is dump truck, 10, toy, and $59.95. Easy peasy. Our key objective for exercise 5 is to delete records from a table which match simple criteria. For exercise 5, we're using a parallel example of TAL6, which says delete every item in the non-game table for which the category is PZL. So let's, again, always with a delete, you're playing with a loaded gun. Let's start with a select rather than jumping right into the delete. Make sure that our logic is correct, and when our logic is correct, then we can go ahead and pull the trigger on changing it from a select to a delete. So let's select star from non-game, and so here's everything in non-game. It says delete every item in non-game table for which the category is puzzle. So let's filter it. Where category equals PZL. Let me make a note about something, by the way, here. I have students that will sometimes say, instead of equal, I'm going to say like. And here's why I have a complaint about that. Now, this one works, but what if down the line we have another category that is similar to this. So if we get kind of lazy, especially if we're using wildcards, say, well, that works for the current data set. What if we down the line have another category type that we've added, and this query is still floating around? So let's say that there are categories PZL, but let's say we end up with a category also PZA and PZB. If you get sloppy like this, your logic includes overly broad results. And so it works for the data set in question today, but it may not be appropriate to the data set tomorrow. So please don't be sloppy. Please be really concise. Think ahead. And let's use the equal operator and make sure that it matches exactly the criteria that we want when it's possible to do so. And it certainly is here. So let's go ahead and select star from non-game where category equals PZL. And here I'm getting only the PZLs. And so back to our original problem, delete every item in the non-game table for which the category is PZL. So I just want to change this from a select into a delete. So we're just going to change this select star to delete from non-game where category equals PZL. And we should knock out 1, 2, 3, 4 rows. 4 rows affected, just as expected. And just to prove it out, select star from non-game. And let's just run that query. And I see only toys, no puzzles are left in the non-game table. That's it. In exercise 6, we will update existing records matching a given criteria and set the field of a value being updated to null. For exercise 6, we're using as a parallel example TAL 7 from the current chapter, and it says in the non-game table, change the category for item FD11 to null. Starting with our usual pattern, let's just start select star from non-game. There we go. And so here's what we're after is for FD11, we're going to change this from a select into an update, and we're going to change the category from toy to unknown or null. Okay. Now, let's start by making a classic mistake. Well, first, let's go ahead and filter to just what we're after, where item num equals FD11. Okay, so we're selecting the right one, and we're going to change this into from a select into an update. Okay, and we're going to say update non-game, set category, and here's where I'm going to make the classic mistake. So I'm going to make a classic mistake here, and we're going to set the category to something where item number equals FD11. So what's the classic mistake? Set category equals quote NULL. Do you see the problem? Okay. When I set the word null into quotation marks, I am setting that to the literal string NULL. This is not correct. It's going to put the word null rather than the fact of it being a null. It's not making an empty field. Let's go ahead and run it. String data would or binary data would be truncated. The statement has been terminated. Well, thank you very much. Let's take a look here and analyze why that is a problem. Probably because the character is the field is probably only 3 characters long. Let's take a look. If we look at the columns on non-game, and we take a look at the category. It's 3. So it's kind of saved us from our folly here. So otherwise, we would have ended up with, let's shorten the string, right? And now it'll run. But if we go ahead and take a look, we now have the word NUL rather than the fact of a null column, okay? So let's see what we need to do to change that. We really want it to be not quote NULL or NUL. Let's make it the reserved word null. Okay, so now that I've set that to the reserved word null, that has a special meaning. Let's run that and update it again. And now let's select from it. And now I have the value of null. This is a null value rather than the value of the string NULL. Okay, so there is a distinction there, and it's an important one. So have a care when you're dealing with that. In exercise 7, our big picture objective revisits inserting records selected from one table as new records on a second table. For the next exercises, the pattern really repeats what we just did using the TAL data set, only using the colonial data set. And so I'm going to skip over some of the background discussion that you already got in the first part of the lecture. And I'm going to count on you to go back or have mastered that, go back as you need to look for the explanation of things and kind of challenge you to apply what you've learned. So we have a preliminary here, and that is before we can get going on colonial, we need an additional table, and it's going to be called the paddling table. Let's make sure I don't already have it here. I don't. Okay. And so you could look back, remember our trick about the paddling table is going to be modeled on the trip table. So you can go ahead and use our trick for scripting that out. Or you can write the create table statement from scratch. And if you need to confer on what the data types are going to be, again, remember you can expand out and look at the columns and the data types of those columns in order to have a guide. And so if you were to create that table from scratch, it would look very much like this statement here. So we're going to create the paddling table, and it's going to have trip ID, and that's going to be the primary key, and the trip name, and the state, char2, the distance, max group size, and season. So a subset of the paddling table. If you look, you'll find there's some differences in the full trip table than from the paddling table, but this is all we need for these exercises. And so execute that, should say that it executed successfully. Remember that you're not going to see the difference here until you come over, right click on colonial and tell it to refresh if you're looking for it to be reflected in the tables view. And now we have the paddling table, and if we were to go ahead and I'll just do a select of the top 1,000 rows in that, we see an empty table, but we have all of our fields that are going to be used for that table have now been created. So we have an empty table, and now we can get down to the actual meat and potatoes of this exercise, which is to do the insert into the paddling table. And so let's again start with a select. Let's get this out of the way. And these are the fields that we want to select. from the trip table, and our select statement is working. So now all we have to do in SQL Server, and this syntax varies a little bit from different SQL databases depending on the dialect of SQL they're working. Some have a select into syntax. We use an insert into in Transact SQL, which is the dialect of SQL that we use for Microsoft SQL Server. And so we simply say insert into paddling and leave the rest of the query alone. And we should see, let's see, there are 9 rows here. So we should see 9 rows affected. And there were 9 rows affected. And now if we come down here and just run a query, select star from paddling, there are our 9 rows. In exercise 8, we will revisit updating existing records in a table using a calculation based on the present values. All right, for our 8th exercise, we're using Colonial 3 as a parallel model. And to solve that, we need to take for all the trips located in Connecticut and increase the maximum group size by 2. And then we're going to update the paddling table accordingly. Okay, so let's just start with a select star from paddling. Okay, so here's our paddling table. And what we're interested in doing is increasing the max group size by 2, but only for those from Connecticut. So let's add our where clause. All right, so now we know there's 2 rows affected. We're successfully filtering for just Connecticut. And what we're going to do is we're going to change max group size to max group size plus 2, right? And here, let's temporarily call that new group and run it. Okay, so 8 is 2 more than 6, 9 is 2 more than 7. So our logic here is correct. Now we need to transform this from a select into an update. So we're going to change this to an update query. So let's update paddling, and let's set max group size to be equal to whatever it used to be, plus 2. And we can get rid of the alias there. We're putting it right back in its original. And that's going to be only where the state is Connecticut. We should see 2 rows affected. And we do. And let's prove those out. And here, Connecticut, we now have our max group size updated. Problem solved. Our exercise 9 objective revisits inserting a record into an existing table. Let's move on to exercise 9, and for that we're using Colonial 4 as a parallel, which says insert a new trip into the paddling table. The trip ID is 43, the trip name is Lake Champlain Tour, the state is Vermont, maximum group size is 12, and distance is 16, and the season is summer. I have thrown a curve at you here, and you need to pay attention to this because there's a really easy mix-up you can make. So let's take a look and analyze what that is. If you look back at the comparable exercise that you did previously, you know that you can steal the template for doing the insert from the script that is generated off of the insert statement. So we can grab a generic insert for paddling in order to do this. So again, if you came over to the paddling table and right-clicked and said, let's see here, script table as a insert to and into a new query editor window, this is the statement that would be generated. Now, what I want to point out to you is that the group size is 12, and in my problem statement, I've stated the group size before the distance, which is 16. Both of these are numeric data types and could be easily reversed. If you give me an answer that says the maximum group size is 16 and the distance is 12, you will get 0 credit for this, okay? If you look, depending on how you built your table, you may have actually built it slightly differently. If you rely on the ordinal position of the field rather than naming the field, if you insert 12 before 16, what's going to happen? Let's see, if we follow this down, trip ID, trip name, state, distance, group size, season, okay? Trip ID, trip name, state, group size, look here. In the way that this table was constructed, the field distance ordinally, in its order, comes before max group size. So if we just dump the position in, then we would end up updating the table or the row incorrectly. We would put 12 where 16 belongs and 16 where 12 belongs. So we have a choice. One is we could simply come over here and reorder it, or we can use the name of the field that, or the field that we are updating. So either solution is good and will work around the problem, but you need to be aware of the problem so that you look out for it. So I wanted to make you aware of that. Okay, so let's go ahead, and before we deleted this out and used only the ordinal position, now I'm going to leave this in, and we're going to update our values, but we're going to have them stated explicitly so that we can see the order of the field that we're updating. So what is the trip ID? The trip ID is 43. And the line break is not necessary. It's just helpful to see because we're lining these up. The trip name is going to be the Lake Champlain Tour. And the state is going to be Vermont. And the maximum group size. Okay, so do I want to go ahead and reverse it here, or do I want to reverse it here? I could do either one. Let's go ahead, since I've said I'm going to distance, so I'm going to say the distance is 16. So notice I'm taking this out of order. And then the maximum group size is 12. And the season is summer. Let's take a quick look. How did we capitalize the seasons? Let's do a quick peek. Select star from, and let's grab it. From paddling, And it's capital SUMMER. Okay, so we've been consistent there. Nice to check for consistency. All right, so let's go ahead and attempt to run this insert query, and we're going to be double checking. Did I get the maximum group size is 12 and the distance is 16? Group size 12, distance 16. One row affected. All right, and group size 12, distance is 16. Yay, I get all the credit. So look for that disordering. It's very easy to swap those two, and because the data types are compatible, it will allow you to make that error in the update. So make sure you get all the points. In exercise 10, we will once again delete records from a table which match a simple criteria. For exercise 10, we're using parallel exercise number 5 from the colonial set for the current chapter. It says delete the trip in the paddling table with the trip ID 23. Let's again start with our usual pattern. Select star from paddling. And here's trip ID 23. So let's add the filter to address only that. Okay, and now that we've got the select logic working, let's change the select to a delete and run it. We should see one row affected. Happily we do. And now if we say select star from paddling, we see an absence of trip ID 23. In exercise 11, we will gain additional practice and experience updating existing records, matching given criteria, and setting a field on those records to null. For exercise 11, we're using as a parallel exercise 6 from a colonial data set. And the problem states the distance for the Pontook Reservoir tour trip has been increased to some unknown number. We don't have a feedback from our GIS people yet, so we need to just make that an empty, a null value. And so we're going to change the paddling table to reflect this. So again, we're doing an update that involves a null value. And again, you want to make sure you don't put in the string NUL or NULL. We want to make it a null value. We also don't want to use an empty string, just quote, because that also is in some circumstances distinct from the null value. So we want to get an actual database value of a null. Okay, so let's start by using select star from paddling. There's all the records, and we need to do this for just the Pontook Reservoir trip. Okay, so here's the trip named Pontook Reservoir Tour, and inspecting the data, I see there's only one Pontook Reservoir Tour. Okay, good to check, because perhaps there were more than one. You know, we're not using, this is not a guaranteed unique criteria. This would be the guaranteed unique criteria. So bears thinking about, are there, more than one trip with the same name? There probably shouldn't be, but are there? Because there's no database rule that would stop that. Only the primary key is guaranteed unique. So worth checking before we go updating. And select star from paddling, where trip name equals Pontook reservoir tour. And I know it's a lot of typing. If you're not a touch typist, students like to do this kind of thing. Don't do it. And the reason is right now, PO will only get you on this particular data set, the Pontook Reservoir tour. But what if next year we add a new tour called the Portland Headwaters tour that would then match this, and your logic, if that query were still hanging around, would and was reused, would cause us some grief. So don't do it. I don't like it. I'll take points off for it. Be precise when it is appropriate to be precise and use wildcards, and the like when it is appropriate to use the wildcards and the like. Don't get lazy. Okay. Pontook Reservoir tour, and let's see if that's working. Yep. Okay. So now we're just returning the one record that we're expecting. Select star from paddling, where trip name, and we're going to change this from a select to an update, and we're going to change the field distance to a null. Okay. So let's change this from select from paddling to update paddling, where trip name equals Pontook Reservoir Tour, and here's our set criteria. Set distance equals, and we're going to use the keyword, the reserved word null, right? Now this is a numeric type, so it should have a fit if we were to do something stupid like this anyway in this case. But just to be clear, this is a null value, and null has a specific meaning of if it's not anything, it's a not known, it's a not specified value, and that is distinct from 0, and that is distinct from an empty string. It is quite literally a null, and so we're kind of picky about that in the database business. Let's go ahead and execute this. This should update one record, one row affected. That's what we expected. That's good. Now let's check it. Select star from paddling. And there we go. And I don't know if you can see it in the recording, but notice that the null value is called out in SQL Server Management Studio. It has a slightly lighter yellow background in my color scheme and settings. So it shows you that it is distinct from the null string, which again, this is a numeric data type, shouldn't have accepted a string anyway. But that tells you that it's specifically a missing value and not a 0 value and not an an otherwise empty string value. It is the value of null. This concludes the lesson.